Hello, everyone. Welcome to the Hackathon finale pitches uh, part of the India Blockchain Week. It's been an interesting 2.5 days. A lot of teams have put in a lot of time and effort into this hackathon, and the problem statement was given by our partners, Barclays. It was an interesting problem statement. We tweaked it around a little bit to ensure that uh, even a wider, to ensure it's an even wider scope than it presented. Uh, First of all, let me just ask, are you guys excited? I really can't hear you. This is a live stream and only audio from the mic can be heard back out. So please, are you guys excited? All right, all right. So let me just introduce you to the judges real quick. Um, would you like to come on stage? Shweta Chawla, uh, AVP at Barclays. Nikhil Verghese, again from Barclays. She was your mentor since the past 1.5 days. Both Nikhil and Shweta have worked on a blockchain POC within Barclays. So, uh, you know, the technical side of things, I'm sure you realized once you interacted with Shweta, they really understand that aspect. The third judge is Mr. Prabhakar Reddy. He's an early stage investor from Axel Partners. Again, early stage investor at Axel Partners. He's been there, done that in terms of hearing out pitches. So I'm sure he can. You know, you have to bring your A game to impress him during the pitches. All right. So I think Raghav has already shared the the list of pitches, who's gonna the order of pitches. We'll just begin immediately after this, and we'll have pitches non-stop. Everyone will get 10 minutes per pitch, including 2 minutes of Q&A from the panel, from the judges. So I'm sure it's going to be an interesting couple of hours. So all the best, everyone. Yeah, that's all.
Uh, so the first team up is a Blockify.
Hey guys, my name is Venu, and it's been an honor to be here. I'm from Hyderabad, India. Um, so we named our team Block 5. We're 5 members, so we called it as Block 5. um, so starting with me, I am Venu, Vikas, and there he's Bala is, the Bala is there, and right. Um, so So what, in response to the problem statement, what we have is a decentralized KYC platform. There is a team which we are presenting here. We tried to do a demo of it. We did the smart contract, but we couldn't get the UI in place for the time, within the time. And apologize for that, but we'll take you through what our thoughts are, and we're open to feedback, and that's what we're here, right? So if we look at some of the facts, and this is from the Global Findex 2014 survey, the key takeaway from this is that 73% of population from the 25 focus countries don't have any form of banking access. Right? There are a few, like you have 25% which have some level of access, and then 51 to 100% who has good financial services. You find Brazil in that quadrant. So this is the state of affairs in 2014. I'm anxiously waiting for the next one. So let's look at why these people are not being able to get any kind of access, right? The key takeaway there again is that the survey finds that irrespective of these people being poor, that's not the only reason why they can't get access. They can't get access because there are a lot of bottlenecks involved. Like there is a lot of cost, people have to travel a lot of distances, and there is a lot of paperwork involved, right? And we take that concept, and what we try to focus on is not address the entire transactional mechanism of banking system, but how we could at least solve even one puzzle, which is the KYC. So what we think is a scalable, flexible KYC solution which resolves these issues, and obviously there is a lot of legacy solutions that in place. Right? You can't start, so this is not an evolution stage, it has already happened. And then, so if we start here and then take this through, that's when we can achieve some blockchain-based solution. So the key is that resolve those issues using blockchain. That's where we are pitching in. There are two main tenets for our solution. So if you give me only 60 seconds, what I do is there are two main pieces to our solution. One is a collaborative information sourcing platform through the KYC, and that's a very novel concept. And I know that it may scare a few, but when you see the whole thing in a holistic approach, that's when you realize that it's very powerful. And the second solution, that is not existing in the market as of today, is what we think is. We're happy to be stand corrected, but selective sharing is a mechanism which puts a lot of power in the user's hand. So what that brings is that it builds the confidence in the user that I can use this platform safely, and I can control what my data is going to be shared with anyone. So this is a pictographical view. So this is how I like to present it. So this is the user's KYC sitting in the middle. There are all these other sources, and we haven't captured every one of them. This can grow in future. The way we have thought of it is there are going to be the telecom companies, there are going to be the healthcare institutions, there are going to be the financial institutions, there are going to be law enforcement agencies, police, attorneys, and then there is the social profiles. Accepting the social profiles, everything else is a B2B platform. So the bank, for example, Barclays, can reach out to these agencies, get the information they want. And so the way this thing will work is, what is the incentive for a specific institution to share anything, any information that they have, right? So this will work as a reward sharing mechanism. So the way, and this is the smart contract that's going to be built into the system. The way it will work is that, let's take a simplistic case that somebody, like I can say Venu. So Barclays wanted to verify Venu's information, and this applies the same to all the institutional investors, B2B scenarios. Accepting that that is not a person, that may be a firm, right? So you go to an institution, you pull the information, you source it from one place, you source it from many other places, right? Now when that happens, you have pieces of information or segregated pieces of information that gives you a chance, a better perspective to put all of that together, right? And based on what you have sourced, you can rank or create a popularity rating for me that the information that is provided by this person is authentic. If you can achieve that by this, and what you have actually done is you built a comprehensive KYC, right? And the same so with social profiles it's a little different. So I give you access, so you get my phone number or whatever, and I give you access to access my social profile. And then what you do is you ask my friends, do you know this guy? People in my friends list or in my Twitter followers whom I am following. So based on that, there can be a ranking system. So this is essentially a ranking system that's built, and whatever pieces of information you have sourced from all of these sources, only once there is a maturity level established, that's when all the KYC gets established. Then what happens is that the third parties, I will come to this. This is the future business model. So what does this allow Barclays, or why should even Barclays do this, right? Like let's say that Barclays spends a certain amount of money in doing a background verification, their KYC verification. Right? With this kind of a solution, all the third-party intermediaries will be eliminated. Whatever process inefficiencies or the delays or the time to transact will be reduced. And at the same time, this is a decentralized model, so there is a smart contract with everybody. So the contract defines how a specific institution is going to be benefited or rewarded for the information they are sharing. Right? There are so many points that I'm not touching upon. I'm just going through the high level. So, and this is a decentralized model. There is an ease of use. Then you get an authentic verification of the profile. This is flexible. By flexible, what I mean is tomorrow, if you want to bring another agency into the mix, you can.
Just have 1 minute of time left before we begin the question answers. Just have 1 minute before we begin the questions.
just one feedback. It would be good if you don't long or spend 7 minutes or the 8 minutes that you have talking about what KYC is, and jump into the actual architecture. Because 30,000 feet talk, actually, we know what that is. Every company, if they start spending 7 minutes, that will not be productive. With regards to your selective sharing, I like the general concept of basically giving only certain data points. Could you talk a little bit more, like a second level deep, about where you're going to be storing this data? How will the data be transmitted to the bank itself? Will the bank be storing the data on their own? Will it be? Sure, sure. So when a bank requests for 6 data points out of the 10 data points, where is the bank storing this data? Could you talk a little bit about that? How is it keeping it secure? And is the bank going to be storing this data forever, or will it be deleted after a certain point of time?
So you said that you're going to keep the private key with you. So what if I lose that? I have just one final question. So the problem statement pretty much described everything that you guys are presented right now. So what would you call your USP of your project over here?
Is a very big effort in itself, right? So the first thing is there are already solutions in place. So what we are doing is we are trying to build a ranking system. So when it matures, what happens is that you are known by your credibility. So more is your rating. So that's very innovative because you are integrating with whatever you have today, and then that is a decentralized model. So tomorrow, even if you want to do an anti-money laundering type of an activity, if a person opens up an account in an offshore location, So there is not that much credibility for that account. So, and then there will be a machinery behind this scene, but it gives the bank and the users that power. Second, obviously, is the selective sharing, because today you lack that functionality to encrypt, send only those pieces of information which you are comfortable. That's what we.
Okay, two questions from me. So you mentioned quite a lot of players in, in the entire ecosystem that will contribute towards creating the user's identity, including healthcare and social. Why do you think that the banks will trust it? Even as of today, Bank A does a verification, then you go to Bank B. Even if Bank A has done the verification, Bank B doesn't go and talk to Bank A. They have to do the due diligence because it's a very regulated market. So why do you think the banks will now trust all these players, leave alone just banks?
That's an excellent question. So this is the reason. So this is the beauty of decentralized world, so that you need not trust one source, and you have many sources. So when you source information from many sources, for example, if people are colluding, like let's say that I uploaded a video and we said like you like my video and I like yours. So we are going to get maybe 100 likes. But if you get 1 million likes, then you can be sure that this information is credible. And then the source is not one. So you have many sources. And tomorrow, if you think there can be more sources, for example, the government type of information is a little rigid. So if you always go to the government type verification process, then you need to request access to Aadhaar in case of India. And when it goes cross-border, then there are many other different complex solutions. So when you bring in all the existing solutions and then you put a rating mechanism in place, then you can arrive at an index that tells you that this KYC is indeed valid or invalid, or that it gives you that there needs to be some additional filter that needs to be.
Okay. And one last question from me. So as you mentioned that the user is in control of what he wants to share with each of these authorities or banks, whoever requests the data. So if a person has a criminal record, why do you think he would want to share that?
So the user sharing part of it, how does it normally work is that's the third party ecosystem which I did not explain. So once you have established the KYC, the way it works is that if some other bank, like you have approached another bank, somebody might approach Barclays that I need this information, right? Then you are asking the user that this bank is asking me to share the information with a third party. Are you comfortable? If the user is not comfortable, you're not sharing. And if that makes the user inability to get whatever transaction they're trying to do with the bank or another institution, that's the user's problem. It's not Barclays' problem. What you're giving the user is control. So they can control what information you are sharing in a secure manner.
So if a user is already authenticated and onboarded onto a bank like Barclays, and tomorrow if there's a criminal record and the user doesn't choose to share that, then how will the bank come to know?
Oh, okay. Sorry, I didn't get that part. So the way it happens is because of there are multiple sources. So there are law enforcement agencies. So the information flows from, so the user sharing of information is only an output transaction, not an incoming transaction. Yeah, so the user is setting the permissions whether he wants the information to go out of the system or not. Tomorrow, so this is a classic scenario, right? User might have committed a felony or something, and for fault of theirs or something can happen. This is a complex world, right? Something can happen. So in that case, the user is not sharing the information with you. The network you have built, that is feeding in the information. So now you have the ability to check. But let's not even go that far. The user has changed his address from one place to another place. The user need not share the information with you. The network feeds you the information because of what you get. I hope I answered that, please. Right, thank you. Thank you so much.
please just request you to restrict yourself to kind of 7 to 8 minutes. This presentation took around 25 minutes. Okay, so next up is Thought Hackers.
Okay, good afternoon, everybody. So we will keep this to 10 minutes or less. So we're Thought Hackers, and we're going to talk about Thought Hack this afternoon. So we move on. We look at the KYC space. We've got 12 teams here today talking about KYC and identity management, but actually out in the outside world, there are already lots of companies doing this, all right? So why do we want to just repeat it? However, we move on to our next slide, you'll see that they're all fragmented. There are some who are providing KYC services, some are providing identity, some are providing background checking, some are providing a wallet. Our USP is that we actually bring those together, and we believe we're the only proposition that provides the ability of the wallet, the identity and identification actually together in one place. So here's a story. See how this goes. Ring, ring.
Hello.
Namaste. My name is Gary. I'd like to rent an apartment, please.
So to prove your identity, I need some of the documents. Can you provide your passport,
Yeah, sure. Hang on.
your work visa,
Yeah.
your driving license,
Somewhere, yeah.
and your Aadhaar card? Okay, I think that might take some time.
Yeah, I need to go and find those. Can I post them to you?
Okay, cool.
So that might take a few days.
Yes, I think so. So I'll be waiting for your reply, like maybe next Monday.
Okay,
next Monday.
this doesn't sound good. I can't wait for this. Let's look at the thought hack way. Ring, ring. Good afternoon.
Good afternoon.
Namaste. My name is Gary. I'd like to rent an apartment, please.
Oh, nice. So Gary, can you please share your ThoughtWorks ID, Thought Hackers ID with me?
Oh, you use Thought Hack. Oh, great. Sure. Hang on a moment. Click. Okay, I've sent that through.
Let me check. Oh, great. I received and verified your identity.
Isn't that much easier? You save so much time. So, moving on. We took a look at the challenges that were stated in the business problem, and we focused on three, which is trust, the uncoordination of all the different identity sources, and the fact that there's little control over personal data and the ownership of it. So we've got three key features that we'd like to talk about today. We use biometrics to prove the identity. So that allows us to do multi-factor authentication, which is much better than some of the traditional ways. We use multiple data sources, and we're going to talk about that a little bit more in a moment. And that allows us to build up a confidence ranking that your identity is genuine, and you'll see the sources data we use on that. And we also use a mobile wallet to actually hold that personal data and the associated documentation, that rather than trying to find where everything is, we can just transmit it through the system. So this is the principle behind the onboarding. We've designed this on the basis that whilst this can look at things like local things like government services, so Aadhaar has been mentioned already, not every country uses that. It's unique to India. So the way we've designed this is that there's a whole range of data services, data sources, and information services that we can plug in. So they may be country specific, they may be financial services. As been mentioned already, banks already do KYC checking, so why don't we reuse some of that? We've got the ability through the app that you take a selfie photo, it uses biometrics to check your photo, verify against your passport photo, that kind of thing. And we also plan to link into other ID services. Whilst it's actually relatively easy to forge a passport these days, it's incredibly hard to forge a Facebook identity because you have to, as someone was saying before about the number of likes and your friends and that kind of thing. And we also retain a complete audit of any requests onto a blockchain as well. So the way that the sharing works, as we've already heard, is that the requester asks for some information. They share through the application what their blockchain ID is. We, in return, validate that. We use a smart contract to validate that they're correct, and then we transmit that data back through the system. Moving on from that, we then look at the identity sharing where we have the ability to actually say to people, well, you can have access to this amount of data for this length of time, and then it gets revoked. So that reduces the ability of the data being left to open. So as you can see, inwards you put in how long they have access to the data and what kind of documents they need, because they may still need the passport photo and that kind of thing, because different companies still have their own KYC requirements. So this provides identity, but also fulfills the need for them to stay with existing KYC methods. We move on from there. So we've developed an application to do this, and you'll see where you've got share my bid, so share my blockchain ID. It's got the expiry date on it, so it is temporary. And we actually say what pieces of information we want to share with the organizations. We've also got the auditing, which tells us who we've shared the documents with in some way. And then finally, we can look and we can say, well, at the moment with Barclays, we've shared these documents for this time period. Moving on again. So it's the question I keep being asked anyway, blockchain, so what? What are the differentiators? The great thing about us using blockchain, and particularly the smart contracts aspect, is it means it's always on. So it's not like you go into a central system that might have a power failure or something. We've got global distribution. So whilst this can be deployed in one country, it's scalable. It takes advantages of the information systems in other countries as well. Encryption and security is very important, particularly with hacking these days, but we only share keys. We don't actually put personal data onto the blockchain itself. So that takes away a lot of the data protection issues about personally identifiable information being on databases. And we use smart contracts to limit the access to each of these documents as well. Moving on again. So why ThoughtHack? We've got certain key advantages to consider. We actually reuse a number of existing services. So rather than building stuff out from scratch, we're actually using a number of the services that are already out there. We put the user back in control of their data, and we make it widely accessible by pulling in the different information sources. So the solutions, trust and uncoordinated little control. You'll now see the way we address each of those three things. Moving on. So time for Q&A and meet the team. Thank you.
You guys, great presentation. You covered all the good points very well, concise. One question I have is, what kind of technology are you using? How far into it are you right now? How much of the development is done so far?
So the development part is we have the app which talks to a backend server, but a lot of the things are still in development. Like we couldn't really connect the whole end-to-end picture. But
let me rephrase that. So what I want to know is how you guys are actually using the blockchain, because there'll be different actors and who all will be the nodes in particular. I'm trying to understand that because it's distributed. So everyone, as you said, that there's no central server, someone goes down. But who are these people who are going to keep it up?
So in terms of the nodes that will be used, that could potentially be the participants in this complete thing. So it may be the banks, government services, if they get support and they want to endorse this, and also notaries who could work out a way of actually monetizing this. By having notaries providing nodes, they could be paid in some way to contribute to this, and then the services that consume the data pay for it. Does that answer the question?
One question. So the benefits that you mentioned, so there's something known as Swift KYC. So Swift is also offering KYC services free of charge, where it does the verification of documents and it provides to the banks. So what is the added advantage that you think that you can provide over here by building this blockchain solution over Swift?
So the unique thing is the way that we pull in multiple data sources. So Swift, because they're in the banking sector and they do the payments aggregation there, they are very good at doing banking-specific KYC, and they only use related data like Thomson Reuters, this kind of thing. Whereas what we're offering is the ability to pull in unique data sources, so particularly social media, where people are using those things more.
So when you include social media as well into the picture, you get a lot of noise in the data. So a person could have multiple profiles over social media. So how would you eliminate that noise?
So it's a responsibility of that user who is uploading his profile. So maybe the user has the control of his own identity. So here the user is uploading the data like the Aadhaar or the driving license or linking the profiles. So he has to make sure that the ID which belongs to that person is connected to the app.
Besides that, a bank, for example, maybe don't want to see your Facebook profile, maybe someone else wants to see it. So they can ask for selective data like, I just want to see your passport or PAN number and Aadhaar card. And maybe there's someone else who also wants to see your social profiles. So you can selectively say that I want you to access this piece of data only, and for this much amount. So after, that contract remains good for like a day or two. So you can have access to a particular set of data for a particular amount of time. So it's up to you, you want to see the noise or not.
So when a bank requests the data from your app, you actually transmit the data, you verify and you make sure on the smart contract that it's actually there. You transmit the data onto the bank as well, or is the data always stored only on the consumer side?
So
Just to add to, I think, his question, so you can answer that together. So where exactly are you storing the data?
So the data, the actual data files would be on IPFS, but it's up to the requester that if they want to access the data as well, and that will be if you're allowed, that if I accept your request, then you should be able to access the data as well.
So the bank stores the data on their end, and
So they'll receive the data.
you'll receive it. So what if I end my relationship with the bank? What happens then? Will the data get wiped out, or will the bank still continue to hold my data?
What if?
I end it, like I'm working with HSBC Bank. I decide to close my HSBC Bank account. I move on to Citibank. So will HSBC still continue to have access to my KYC data, or will it be revoked? How does that happen?
So currently, what we have thought about is that you get the data and it's off the network now. Like you have the files, but we can think about like having an interface of our own where you won't be able to get the local files. So this is a kind of problem. Like if you can see the data, you can easily copy it. Like if we encrypt it, you can take a screenshot or something. I mean, it's a whole different problem, I think.
So when just one last question. So when I send in documents to you, if I give you a picture of my passport, is that stored on the blockchain?
That would be on, that won't be on blockchain, that would be on the storage IPFS.
Okay, so don't you think that will be too bloated? There are 1 billion people in India storing so many records. Don't you think content management in itself will become a problem later on? Because, and how your blockchain is kind of interacting with that content storage mechanism.
Thanks.
So the total presentation time here was 14 minutes. These guys timed it really nicely. 8 minutes precisely you took. Okay, so the next up is Rapid Cube.
Guys, a wonderful day. Actually, let's. Yep. Am I audible? Yeah. Yeah. Hi. Um. Yeah. So our solution here is like it's been a wonderful day, like yesterday, today. So um, the existing problem that everybody faces now, not audible. Okay. Um. Okay. The KYC is something that every industry uh, has a problem in it. So every industry needs it, and it is the problem is distributed. So nobody trusts each other. But the problem everyone has it. So there needs a solution. There's a loud cry for that solution to come up. So that is why even though there is like n number of solutions, n number of legacy system, the ways and process differs from person to person, but still the problem still exists because of the trust factor. So what we try to do here is we've tried to build an application on blockchain for two reasons. One is to bring up this bring up the people and the organization together, work together. So it cannot be a completely people-owned solution, or it cannot be completely an organization-owned solution that would actually work. It has to be a win-win solution on both sides. So ideally, the thing is that a person should have the control to what he wanted to share or how long he wanted to share. And similarly, organization also has to have the control, saying that when he needs, whenever he needs whatever data he needs, what kind of access he needs, actually he should be able to request it back. So, so our solution, instead of talking the problems and thing, I'll just jump into how the solution works. Um, so So if you see that the key idea, key things that we try to put in our solution is one is that the all tenants that the blockchain provides, immutable, it's trust, it's provenance, it's very transparency is there, and there is a zero knowledge proof. Zero knowledge proof is instead of giving you the information completely, just give that proof saying that your information is authentic. But it's not possible for every KOS to you give that, but certain things you definitely can do it. And the flexible identity is actually is the most thing that every other team's also been talking about, like sharing only the necessary information that you wanted to share. And we also thought of adding the GDPR compliances, if not everything, like forget to closure, and I'm sorry, forget to erasure, and auditable data, and notification when there's a data breach, things like that. Um, so how the solution works, user will actually have a profile which will be building with his documents. These documents will be stored in a cloud, basically, and this cloud actually will have the data that is encrypted and stored in the cloud, and the hashes of these documents will be created, and the transaction that's happening. Let's say I want to share my information to one particular bank, and I want to revoke the information back from the bank, and I want to delete the information completely. So these are the transaction information that actually goes into the blockchain. So that is how our architecture is built. There is a cloud, it's a hybrid, it's a cloud, and there is a transaction ledger, and there is an UI that is, talks to a server, and this is how it's managed. And it is pluggable with another APIs that is, that actually talks to the government APIs, because it's not possible to verify all your KYCs only with the people around you or with the social. It's actually necessary to verify with the government agencies as well. So, so it has a pluggable APIs where the application talks to the APIs, and as well as when there's a self-sovereign identity, which means that when a person creates his profile, he he certifies himself, saying that whatever the data that I've given is right. And then whenever there is an bank certifies it, or whenever insurance company certifies whether your data is valid, and they keep adding badges doing saying that I have verified this document. So that way, what happens is the more badges you earn, which means that more authentic your data. So these badges is not the principle is these badges are not given by your friends or family. It's actually should be done by the prominent players of the industry. So it should be a bank, or it should be a known government authority, things like that. So it's just a simple depiction of the entire architecture. So there'll be institutions, banks, users, and the document stays in the repo here, which means that your document can be removed from that anywhere, because if you're going to keep that in a blockchain, blockchain cannot hold a huge data, and it cannot be deleted. So the documents are going to stay here, and only the transaction information is going to be there. So that is the ledger. So what we've used Hyperledger Fabric, because we believe that this kind of information has to be in a permission ledger. So that is what our USB also. So yeah, this is how it works. I would like to show a small MVP of what we've done. So yeah. It's a small mobile app where where there are participants, like there is a bank registered and there is a new user registered. So I'm like trying to log in as a simple user. Yep. As soon as the user registers, actually he keeps continuing. So as soon as the user logs in, he will have a QR code, and he can build a profile. Here just it directly enters the data. Otherwise, it should be a document uploading. And once it is done, there is a QR code by which bank can simply scan and get the data. And similarly, bank can actually manually request based on using an email or some contact name. So that is also possible. There is two way of sharing your data. After sharing your data, there is if you can see, there was a button like audit trail, which actually also shows you when your data is actually when the data is shared, to whom the data is shared, and how long it's gonna be valid there. So it also user also has the power to revoke the access back as well, and he has control to delete the data as well. So yeah, this is an MVP which has like where user can share information. So this is the notification that got a request from certain company. You can accept or reject to share the information.
I think we're up with the 8 minutes. We open for question answer.
Yeah, I'm also done with the demo. I mean, yeah. Thank you.
So first of all, great work for having a demo as well.
Thank you.
So my question is that, as you mentioned that you will be storing data on a cloud, and so how will you manage different countries, different regulations? Every country has a different requirement. Every country has different unique documents that are there. So how would you manage that across?
Actually, this current MVP actually I focused only based on the Indian region right now. So adapting other countries, different languages, it is adding a document is I mean, it's scalable. It's already there. But adding in regulatory, it has to be done individually as per the region. It is not. It's mere difficult to bring in common way of authenticating entire thing across the border.
And what happens when the first time a user uploads the documents? Does the bank then needs to verify those documents? I'm
When the
talking about
first user,
first time user.
the first time user, it has to be verified by the bank because that is how it works. So there should be one time verification done by somebody.
API. So once an Aadhaar number or something is uploaded to the system, we just connect to the government and validate the Aadhaar number. So the person who is going to upload his information will be using a mobile through which he is going to upload it, right? So the mobile number and his Aadhaar number can be validated with that in the repository of the government APIs.
So who will contact the government APIs? Will it be the bank or the user?
No, we will be having the smart contracts, which will be having the APIs designed, which will plug to the government and get the data. So it is the validation with certain government certificates will be automated in the system.
I think we'll take one more question.
If the fraud, if the forging is happening in the very source itself, right now the solution, I've not thought through it. Okay, it is how it works. So now, as of now, it is an assumption that it is okay. So maybe I'll think. I don't have that.
And for your first question on the cloud-based solution, like what are the challenges that we cannot depend on only one cloud-based system. Say we are storing the documents on the cloud, the hash of it will be in the blockchain, right? And the documents which we are storing on a cloud should also be in a distributed system. It cannot be again in a central node, central system. Then the entire objective of blockchain fails in that case, right? So we are having a distributed network to have this images. Like the previous team was talking about IPFS. We don't want to go with the IPFS. We want to have our own set of distributed nodes where there is, the logs, the documents will be stored there.
Thank you.
Okay, thank you. Okay, thank you. This precisely took 11 minutes. Next up is Betablox.
Okay, yeah. So, hi, I am Pranjal and this is my team. So, quick introduction.
Hi, I'm Naresh. Hi, I'm Janish.
So, I am going to start with asking a question to you guys. How many of you are into blockchain? Okay, so I'm gonna rephrase. Okay, so I don't know. I mean, how many of you understand blockchain? Pretty much interesting. I mean, so how many of you have read the Bitcoin research paper and they understood it well? Yeah. So I think we are going to be interacting, like, because I have read it like so many times, I still couldn't figure out what the blockchain is. But yeah, we all are trying very hard to do that. So quickly, we are going to start with the blockchain-based identity as solution. So, so first of all, I would like to list some assumptions which we have made. So on the blockchain, so we cannot always start from scratch. So we have assumed there are certain parties which are already registered onto the blockchain, such as government Aadhaar centers, passport centers, and citizens. They have already certain IDs onto the blockchain. For the purpose of our demo, we have only 4 parties on the blockchain, which are government, Aadhaar authorities. Go back, please. And citizens and service inquisitors who will require KYC. And KYC is only provided by the government because if you go to any third party also, anyways, they are going to validate your documents which have been issued by the government. So it is better to go at the core of it and get it verified with them only. And the last part, every party recognizes a KYC being done by the government. So that's what makes the blockchain. Otherwise, it doesn't make sense everyone going onto the blockchain. So this is a quick overview of our process, what we have done. So government will authorize all the authorities who have authority to do the KYC for the citizens. So these include Aadhaar center, passport centers, and all of that. And everything is being maintained through smart contracts. And for citizens, they have their total control of their identity and personal data, again secured through smart contracts and restricted through smart contracts. Basis the request raised by the service inquisitors and basis the permission given to it by the citizens, they have the option to look at the data given by the citizens onto the blockchain. Next. So yeah, demo time, sorry. We are short of time, so we have a lot of things to show you guys.
So we will be starting with actually directly our product. So this will be the first interface you will be seeing. And on the right, you have the main Ethereum blockchain we are using as of now. So you have the blockchain working. Just a second, sorry. So this is the first of the first interface. So this is the government which is entering. So basically, if you want to register a new Aadhaar center or something like a new PAN card center, so the government of India logs into this, they directly authorize a service. So basically, everything is recognized by their name and their public key. So I recognize authority with the public key given as an Aadhaar authorization center, and I authorize it. So basically, you'll see that this is the basically my wallet. So government has to sign it with their private key. So with government doing this, so just a second. This. So we actually have a transaction waiting. I don't. Just a second. I'll need a little time. So it's exactly working on the blockchain network as of now. So we are facing a little issue. It's not working. So sorry, yeah. We'll walk through it. It's not working as of now. I don't know the reasons. So this is somewhere where the government will log in and assign the roles. This is one of the user who has already registered. So he'll put in some of the details, maybe the name, email address, mobile address, something like that, and submit the details. So the other tab for the user is to authorize. So basically he needs the permission, give the permission to someone so that they can authorize the thing. So basically, like if you want to authorize your PAN card, so you need to give the information to the right authority. So this is the portal for giving the permissions for that thing. There are 2 types of permission, just a read permission or a write permission. So how it works is like a write permission can only work when the government has authorized them and the user have authorized them. And so the next thing is like the authority. So basically when the authority logs in, So he has a complete list of all the citizens who have applied for the verification from them. They view their information, and if the information is new, say they want to enter the information into the blockchain, only an authorized center and authorized by the user can enter that information. So he basically enters the Aadhaar information. Say if he was asked to write the Aadhaar information, he puts it into it. So the other added advantage is like we have given the user the ownership of the data, but still in certain cases, government has the rights to uh, like invalidate the KYC. So in certain terms, like if some certain rules and regulations of the country are not followed, the government has the supreme authority to invalidate the KYC, not changing the data exactly, but just to revoke the KYC which has been already done. So that's what basically it is. And now we'll talk about little what this is something which we were trying to implement just in these 24 hours. So what we think of it as okay, what we think is like we got much more. We will try to do is like as of now we are only having the governments, but what we trial is we'll have more people into this thing. So basically banks may be there, or maybe the demat account service providers or the exchanges might be there. So we'll take the weighted average of everything. So over a period of time, we'll be using machine learning algorithms to create a weighted average sort of stuff. So like a government entity has some weightage in saying whether it is verified or not. Bank has some different weightage. Each bank has some different weightage, and it is basically using the data which has been authenticated by the users. Like with period of time expanding, the verification process, the credibility of the user and the bank will keep on changing depending on how the results have been. So that's what we try for a future, and like we'll be using big chain DB in the future because it is meant to for a database. And as of now we are using Ethereum. Still it takes around 8 rupees for a single KYC to be held. It's like as of now if creating a Aadhaar, it takes 2500 rupees to create a single Aadhaar card. But with this system on the public blockchain network already well established, we just take 8 rupees for a complete KYC to happen. Yeah.
We open it for question answers.
So yeah, one more thing if I would like to share with you guys. So we have one more thing. So once the user registers and get the KYC done, he has its own digital identity. And if you let me, I can show you a quick demo of how instant KYC can be performed just by scanning a QR code. If you are interested, like I can show you a demo. Okay, so yeah, sorry due to time constraints. Questions?
So the data, where will it be? Where will it be stored? Will it be on the blockchain? Will it be plain text? Will it be visible to everyone? Because you mentioned about read-write access, but how do you control that on the blockchain?
So as of now, we are building on we build this on Ethereum. So we are storing the data on the Ethereum. Still, it's using the 8 rupees only. So the thing is like you having the data in form of say name and other variables. And this data as of now is stored in the blockchain. In future, we will be storing it on the BigChain DB. So basically BigChain DB is a database running, which is running using the blockchain system as its core. So basically you'll have a distributed databases which is cryptographically saved, and only with the proper private and public key you'll be able to access the data, or with proper permissioning you'll be able to access the data. So that's how we plan it for the future. And as of now, we are storing the data on the blockchain, and it is not costing much. So 8 rupees is the cost. That's the major factor.
So, how do you plan to monetize this?
So monetization will be happening on the terms. So like if we set up a private network for this, so every KYC will be happening at some cost for this, because if the government is taking in the initiative, so government might do it for free, but you could have more validating nodes. As we said, like in future we'll be having more banks, more exchanges on the system. So if you want to information to be verified by them, so you'll have to pay a small fee. That fee will be very small because it is using a common system. So that fee will be the incentive for the bank to verify the data, and that is, why the user will be paying the fee is because the more verification he's having, the more credible the information becomes.
I think that is enough incentive for the user. I heard you mentioned about machine learning
Yeah,
algorithms and
so
trying
that's
to.
where, because like that's where we are using the credibility part. So like there are 10 different banks, but how do you judge which bank must be having a better say? So we are judging upon these parameters. So like after 10 years down the line, what's the detail? If you like, it is obviously assumed that majority is always correct. So if 10 years down the line, if the details verified by the bank stays the same, so bank is credible. But if at certain point of time you realize that the bank verified the information that was actually wrong, how do you comment on how it was wrong? Because 2 years down the line, the information was actually said as wrong by the majority. So you basically decrease the credibility of that bank, particular bank. So that's where we're using machine learning so that we can judge comment on this weightage model.
We'll take one more question.
So I like this whole weightage model, but what if there are limited players in this weightage model? Assume there's one bank that is given the data into the ecosystem, right? And there's a party number two who actually requests for this data from the bank. And I do all my transactions, but the entire chain was fraudulent. So is the bank which did the KYC responsible for it, or is this player number two?
First, we are already having the government as a major node. We have some weightage given to it. And with time, that weightage will be changing. So that's the reason you will be having at least a majority, and you have to trust the government in these cases, because the basic things you are using, you're giving the KYC, it's already on the terms that the ID is issued by the government. So if government is validating those IDs or creating those ID on the blockchain system of ours, so basically you trust those things. And if we have more and more parameters added, that's basically to increase the efficiency of the system.
So the base ID is always going to be the government ID that you
Yeah,
can release.
as of now, we'll starting with the government, and with time we'll be changing the parameters. So when you have more systems, the weightage of the government will be reducing, obviously. But as of now, it's the superior authority, you could assume it. But with time, say like 10 years down the line, when we have 13,000 banks on the system, or maybe 10,000 exchanges, something like that, maybe. So then at that point of time, the weightage average of the government will be very relative to a very trusted bank.
Good job, guys.
Thank you so much.
Thank you. I would request the speaker to kindly hold the mic near the mouth, because nothing is being audible on the live stream. Next up is the Centex. Skeptic, sorry. Sorry.
Hello. Hello, hello. Hello, hello. Hey, good afternoon, guys. I hope we give you the impression that we don't take anything for granted. We are not expecting that government is going to roll over and give us what we want, or we're not going to hope that infrastructure is going to be better anytime soon. What we are going to do is rely on existing digital bookkeeping records of the government to provide PII communication between the banks and individuals without the need of trusting us. Right now, at this stage, we can't claim to be completely decentralized, but we are at the edge of what is possible, and we have a working model.
Hi, I'm Khyati. Allow me to share a personal experience. Around 97, 98, government came up with PAN card. I enrolled, took my card, and soon after, I left for my studies abroad and work abroad. I come back after 10 to 11 years. I get myself a job, and I give my PAN card as requested. They send all the details to the bank to open my salary account. 1 month gone, 2 months gone, 3 months gone. No response. All I get to know is it's not valid. It's not working. So I don't get salaries for all these 3 months. I'm not actually on the employment roll also, because there's no verification. Eventually, I come to know my name is replaced as Kavita. The card says it's right, but in the database, it's Kavita. I had to prove again, who am I?
Yeah, so what Khyati was talking about is an individual data owner's perspective, right? So data is owned by individuals. There is also the other stakeholder,
which are banks and other institutions which actually want to use this information. Now, banks and other institutions have a bigger challenge here, right? So if you look at the status quo, it's a huge expense for all the banks and financial institutions. These are some of the some data that we've taken globally. So it's labor intensive. There are hefty penalties for wrong KYC or not doing KYC, limited control over data, time loss. So it's a huge issue that both from both sides, right? So what we propose in our solution is we want to give ownership and complete control of one's data with the individual, right? And banks and financial institutions get an opportunity to verify that information and use it for their KYC processes. So our solution is called One ID. So it's going to be One ID, which is going to be used for all your KYC as well as your data owners requirements. So essentially the whole idea that we're looking at is the data owners today have the opportunity to be able to store all their information in a smart wallet, which is a digital wallet that we're creating. So they can store all sorts of information which is related to their personal identity. And this can be shared with people who are wanting to verify that information for KYC purposes. So you have different agencies which are going to be involved in this. And there are approvers and agencies who are going to help us improve this process of rating and ensuring that this data is correct. So this is the core stack. We essentially have developed this system using Ethereum. This is essentially how our ledger looks. So we are looking at using Ethereum as a core framework. We've developed a D app, and we are going to use a smart contract model. We're going to have artificial intelligence and machine learning that we will use essentially to read data from the documents that get uploaded. That's one important element that we've tried to introduce in this. And this is typically how the process looks. So how are we different and what exactly does this do? Now the status quo is that there's identity theft, there are labor costs, there are hefty penalties, there is expensive process, time and paperwork. How are we going to change that? So the data, the ownership of the data is with the individual, right? There's bare minimum human involvement. We're also bringing in authenticity and traceability and digitization and instant verification. Like Praneeth was mentioning, we can't bypass the existing system. There are governments who can have control over data and verification protocols, right? We can envisage a world 5, 6, or 10 years down the line where everything is going to be completely decentralized. We're going to make a beginning here. So we would like to look at a system which has two elements. So if you look at One ID, there are two elements to One ID system. The first element is first of all, we're looking at the data authentication itself from the source. Then we have the verification processes. When we talk about data authentication, give an example, let's say Aadhaar is my personal identity. It's information that gives me, it actually gives information about my name, my date of birth, and other information that I can store. Now, Aadhaar as a system today has an API, right? So we can get into the Aadhaar system and use that API to our advantage, but the control is anyway going to be with the individual. Like a lot of others have mentioned, our system also, the individual has control over what data to share, how does he share it, right? Yeah, so we'll show you a demo of how the system works. So essentially, I said there are two levels. We start the process with by creating a wallet. This is actually a live demo. We're actually using Ethereum to create hash for every transaction. Yeah.
Yeah, we are signing transaction with the MetaMask wallet.
So what you find here is that the hash has been successfully created, which means the user wallet has been created, right? And this is typically what
transaction is being processed in the test net. This we have hosted, deployed in the test net.
So now the wallet has actually been created. Now I need to start entering all the details, all the documents, all the ID related things that I want in my wallet. So just for us to demo, we are actually doing an Aadhaar. So again, what happens in the background is that there is an API that we've built. It'll automatically go to the Aadhaar system, verify the information, and then write it into that person's wallet. This information is stored. Now we've come to the customer or the bank's side. So any bank who wants to actually request information will come here and request access to that person's identifiable information. There you see it's happened successfully. And so here, again, we've come back to the blue screen, which is the user. So the user is now actually, the request that has come, he's actually approving that request. Again, we go back to the bank screen. So when the user has already accepted the request and he said, okay, you can take this information, we move back to the bank. So if you see the status is approval is pending. So the process is happening at the back end.
I think we'll open the, we'll open for questions.
Sure.
So what happens if a user doesn't have any Ethereum in his wallet when he has to approve a request?
The user does not have any Ethereum in his wallet. Yeah, so what the onus is on the individual. So typically what we are saying is your identity, you have to protect it. So we tell them that you have to put, if authentication is done today, the user actually spends money, right? So there is a transaction fee that the user pays in the fiat currency or rupee. So we will ask them to start, having some Ether in their account, right? When the wallet was created. Yeah.
And you mentioned you're using some artificial intelligence to read user IDs. What exactly is that? Can you
So the documents today, so I was talking about existing systems, still legacy system. You still have processes where documents are still, digital format, let's say PDF. You need to read that information.
Just OCR. So where's artificial intelligence coming in here?
So we have to read that information and ensure that if there are multiple documents, right? So we have to be able to take information and see if they are related to each other. Right? So that's something that we're trying to do with that. And going forward, this information can be used to our AI and ML systems to be able to come up with a lot more analytics, right? Which will help us arrive at, see, we've got a concept of, reputation index, right? So we're going to look at, and the one question that, in fact, when we were talking yesterday, she was talking about, once this verification happens, now what if there is an event that happens where the passport or, the person has done something wrong and, so we're going to use Oracle to be able to update the system regularly. So if there is a flag, so information that is getting collected real time will get updated into the system, and a flag can actually flag it, so that you know that the process is completely up to date, real time.
So going by, you used all the technologies that is available right now.
Yes.
And you're on Ethereum.
Yes.
So assuming that you're in a place where the government is willing to invest in blockchain, but it says that, I want a private blockchain. I don't want to be involved in Ethereum.
So this is platform agnostic, supposed to we do it, but we have expertise in Solidity and Ethereum, so that's why we did it that way. But it can be Hyperledger Fabric, or it can be.
Yeah, it will just make process cheaper. Because cheaper, the government wants in their own blockchain at their expense.
That'll be great, because ultimately it's the government which has the control over all the compliance related issues. So from a perspective currently where the people are not sure about whether this is going to work, and we've always seen that government follows what the market actually does. If they see that somebody is able to prove a system which is working, you'll eventually have government saying, okay, we'd like to get into this, right? And we are, as of today, we're running actual real POCs, and we've been talking to some government officials who are showing interest, saying this technology itself is good. How does it help us? It'll probably take us some time, but we have to show them that there is something that we can showcase which can work, right?
So the Ethereum blockchain, when you create a blockchain, so it's not a database. So you can't simply run a query as to, can you give me all the past transactions of a particular user? So how do you plan to answer queries from auditors and regulators in terms of whatever has happened?
You can read the log as whenever you want.
I don't know if you noticed that for third slide, there was a features, and there was a below section, we had a developers community that can develop API and apps and provide support. So we included that part as well. So.
Okay, thank you. Just a request another time that please speak into the mic because people on the live telecast are not able to hear anything. Next up is right mesh. Yeah, yeah. No, there is. I think one team was missing. Crypto node was not there. We call the next team is tech racers. Tech racers.
Okay, hello everyone. Uh, so Blockchain Square is our solution to the KYC problem. And we call it a square because what we believe single blockchains can't work for KYC. Whatever solutions we have seen till now is based on a single blockchain. And we are making a couple of claims out here. It's a globally non-duplication, discontinuous synchronization is one of the key features where different banks, different countries, different consortiums can start the KYC process without being connected to each other and then still end up synchronizing their data after a certain period of time or even after a couple of decades. On-demand scalability of data, stepwise migration. I mean, you need not migrate the whole data or all the categories of data. Customers, you can do it group-wise or stepwise. Obviously, as everyone has been discussing and is the problem statement, customers own their data and give time-wise access. There's one more dimension to the time. Suppose I'm making an application for a loan. The bank says I need 7 days to process the application. Okay, I give the 7 days access. But in case the loan is granted and the tenor is decided for 5 years, automatically the access extends for 5 years. In case the loan is rejected, the access closes there. Chain square for data consistency, one of the most important parts. And the next part, and since we are shifting the data to blockchain, there's an additional future revenue potential which the banks can have and also helps you compete with peer-to-peer banking. And we have also built in revenue models for service providers who would be hosting your blockchains. So I'll just run you through the whole solution. The process starts with the global public ledger. And this is a public ledger of hash. The hash are generated for every record for a regional ledger. This both are blockchains. This can be individual bank, this can be a consortium, this can be a country level hosted, it can be anything. But for every record of customer master data that you enter here, a hash is generated and which is declared here globally. Customer puts in a data which is verified by various agencies. These various agencies cannot just be government agencies. I want to take a health insurance. The insurance agency needs my age, weight, height. Government's not going to step in to verify that data. So it has to be those specific agencies which are approved by those banks, wherein I need to approach them to verify my data. I'm taking a loan against property. Those agencies which value my property are going to be different. The car values are going to be different. This all comes back to your core data. So there can be various users who want to access your data, who file a request. You give the consent based on the what time period or product you're giving it, and accordingly they get the access. Obviously here, because there is verification before the transactions are added to the main blockchain, you always have to use a multisig here. Okay, and nowhere here are we talking of any smart contract or anything which adds to the cost. Here you have one more player, which is the KYC provider or the service hoster. These are not the people who are going to use that information eventually, the banks or any other financial institution. These are third-party people who have to incur cost to store this data and manage those servers. Now the question comes in, since customer is the owner of the data, why would bank pay for it? Because I'm going to first verify my data and then approach a bank for a loan. So two models, either the customer pays for getting its data verified from variety of agencies for whatever product you need to access, or the second part is, this guy can say, okay, I'll do it free for you, provided you allow me to market this data and generate some marketing revenue out of it. So maybe if you're in working age and you have certain income criteria, there'll be a lot of people who will be interested in sending some advertisements to you. Again, that can be controlled by the customer. Okay, so it eventually looks like this. You have different groups of non-connected blockchains where you have users, you have people who need data, you have verifying agencies, you have your local blockchains, an individual bank or consortiums, and everyone pushes the hash which to a global database, which is known as and when the data is created. Now take an example, you have North Korea, and you have a banking system there where the data is not open to any of the other banks or outside world. But still, if they manage to push in their hash data to the global system, 10 years down the line, suppose those banks was to join the mainstream, and a guy out here wants to come out in some other country and do some business. You will see I have such a good credit rating out here, but you'll not accept it because you don't rely on those or you don't trust that banking system. But when he says, see, I have been pushing my hash data and it's been existing here in your global data for last 10 years, you can always calculate back and check, verify my data. That probably will help you trust that data more. Yep. So these are some of the questions which you may want to ask. And there were a lot of claims which we have made, matching your challenge, which probably we think we achieve all your points. So questions, and then we run to the technical round. We have worked out all the flow. We have certain code demos also on the blockchains. Just run quickly through it. Or first the questions, how would you like to go?
Or that. So what we are having is that we are going to have two blockchains. One is going to store the informations related to documents. So say when I upload my Aadhaar card or PAN card, I will store that into an IPFS, and then by encrypting it, and the decryption key will reside in a private kind of blockchain for say Hyperledger. And then what we are doing is the hash of that transaction is going to be stored in a public blockchain, that we can trace it down whether the private blockchain has the data which can be trusted. So when we upload a document, play this video. So what we do, we first store it in IPFS by encrypting it, and then the decryption key is stored in the Hyperledger, and the transaction details and the hash of the complete transaction is stored in the global public ledger. For now, we have used Ethereum smart contract to just store the data, but in later time, we will be shifting some on other blockchains that are going to be a perfect fit for this. But the documents and the transaction details are always going to be in permissioned blockchains.
I think we'll open for questions.
public blockchain which is containing the hash, how will the consensus happen? Because it's all crypto data, so nobody can verify as to from the source which is coming, is it authentic source or not? Nobody will know. I mean, I could just push a data onto the public blockchain as well.
So basically, when the data is stored, the identity provider is always going to be a trusted party for say government agencies who will manage their private blockchain with multiple nodes. So consensus is not the key. The key is that they will be pushing the details related to their transactions in a public blockchain, which is always trusted, and we can verify the uh, real transactions in the private blockchain through the public hashes that we have.
So the public blockchain doesn't actually need to be a blockchain.
Yeah.
It could be just a centralized database where inputs are coming from multiple different.
Well, that's where the whole solution actually is. It's Bitcoin Square. Sorry, the blockchain square. And it's not a simple blockchain. The reason being, once we put in a record here, whatever master record we are putting in here, we generate a hash and store it here. Suppose we are not storing the hash. What happens is, once I'm generating a block out here, and I store it in a blockchain, so I have to generate a hash value, add it to the new block. Now that's where the biggest vulnerability of the blockchain system is there, which no one has actually discussed. See, till you're using it as a transaction, it is fine. Once you're using it as a master, it runs into a different dimension where that vulnerability becomes very critical. So what we are doing is, the vulnerability is that once I generate a transaction and I have a hash value for a block, I can replace certain transactions and still manage to get that same hash value. So when a value in block is replaced, you'll not be knowing it has been replaced. So therefore we square it. What we do is, for every transaction we generate a hash, and we have a hash for the block also. And you have the blocks being generated here, which has a hash value. Now try replacing it here. You may tally with this hash, you'll not be able to tally that hash. Or you replace a value here, that hash is tallying, this hash will not tally. So that makes your data absolutely tamper-proof, which is one of the key requirements probably from the banking side. So therefore you need a two-level blockchain to solve this problem.
So let me rephrase my question. The key attributes of a blockchain is that there are multiple non-trusting parties that contribute towards a blockchain. At the same time, those are the parties which also come to a consensus that, okay, the next block that is being added to the blockchain is something which we authenticate and can be cross-questioned by rest of the parties.
Absolutely. I mean, for that you can use the simple
So
hashing
why
formula.
can't it be replaced by a simple centralized database? Because what I
No, it cannot be because of this. I mean, if there is a data tampering happening and you're not hashing it here, you need a block hash here also. And this for consensus again has to rely on the basic Bitcoin kind of a code, which when you need not increase the complexity of the hashing, has to run on a very base level hash. And it's again by the majority, because when a block is being generated, you have so many transactions floating around. So, I mean, with that simple hash, whoever is generating the first block, some transactions may be left out. So again, you need a consensus mechanism there, but then, I mean, it's not the kind of mining rush that you have there. And the rule here is that for a global public ledger, if you want to access data from here, you need to host that server.
Okay, so you're using two different blockchains. Can you tell me which blockchains you intend to use right now?
Today, what we have done, I mean, the solution what we have worked now is where we have used Hyperledger here, IPFS for file storage, and because I mean, our trend is in Ethereum, so we use that. But actually, I mean, both are not the correct things to use. If we have time, we'll like to use some different customized blockchain.
So Hyperledger is private, right?
No, it gives you more control for the access. I mean, you can define who accesses what sets of data. But since this is a specific application, you can always customize a new blockchain for that. That will be much better. I mean, you can always do it on Hyperledger.
Feels kind of strange because you're essentially not trusting one blockchain.
No, we are trusting.
See,
again, see, I don't want to declare this data, or I don't want this data to be shared globally. Still, I want to say that this data has not changed over a period of next 10 years. So what I have to do is I have to release the hash value of my data globally. not releasing my data, yet I'm giving the hash value. So 10 years down the line, when I come back and say, see, this is my credit record, you have a reference value how you evaluate it.
So every time you do an audit trail, you need to go to the public ledger.
Absolutely. I mean, suppose
What we are doing is that we are storing data in a private room. We have a private blockchain which is controlled by a central agency of government. But when the hashes are released on timely manner for today's record, 10 year down the line, when someone will ask whether your private ledger is not tampered, you can just release your data of that private ledger and you can ask them to verify it with the public hashes that we have released when the original data was committed on our private blockchains. So I am keeping my data private, but on later time I can also validate it, and other parties can be certain that their data is not being tampered.
We can see we can take audience questions later. I mean, you can
Every time
off
we have a day when every transaction which is being recorded on the hyperledger will have hash will be generated for it and will be written to a public blockchain.
we thank you guys. Next up is right mesh.
So I'll tell you when to switch. Okay? You have the mobile phones ready? Okay, good afternoon, everyone. We are Team Right Mesh, and we're introducing a concept. It's quite big, but we're solving an identity solver problem like everyone else. So we are Team Right Mesh. We are a multicultural and cross-functional team from Khulna, Bangladesh, where my tech team is, and I'm from Vancouver, Canada. Many thanks to Rise Mumbai and IBW. We just had a great time. So really the problem statement is around blockchain-based identity system. We know that. I think that's the obvious thing that you all need to solve. There are the salient benefits behind the blockchain, which really makes sense for an identity management system to be implemented in the blockchain, including the global availability, the permanence of data, the immutable aspects of it. So that's all we know, and that's obvious. We're not going to get into that. But when we analyzed the problem statement, it was really, what is it that we can achieve? What is really the problem that we want to solve? And when we looked at it from end to end, we really looked at the whole concept of identity creation and how that system is basically managed. Because when you look at it, there are a couple of barriers towards ID creation from a institutional standpoint. So as many people have already talked about, the whole KYC process being extremely inefficient in terms of costs, time that's required. And while it's a nuisance for users, just think about the institutions, the banks, that really have to shelve so much money, which is non-revenue generating, non-differentiating. In terms of infrastructure, about having all the different systems that are out there which collect information in disparate ways, which have no uniformity at all, and basically is, again, a lot of inconvenience across the spectrum. Finally is human barriers. So once we talk about, we look at the whole spectrum, there's one side of the population that do have these documents and just need time. It's a complex task. But what about the bottom side of the pyramid? So when you think about it, it's really that bottom side of the pyramid, a good 1.5 billion, 20% of the population that don't have any records at all. And they don't have, they have problem with identity management. So the challenge that we kind of made for ourselves is, one is to create a system to create and use global identities by minimizing the efficiencies in the whole KYC process from the demand side, or from the supply side rather. From the user side, we wanted to create a system that would have an easy experience to create and use an identity system. So when you look at it, the inefficiencies is really about the whole documentation that needs to be provided, the verification part. This has to be done for every customer. When you think about it, why is this all done? It really comes down to trust. And trust is really, about the whole thing about identity is really kind of identifying that you are a real person. That has to happen. And are there different ways to think about it? There has to be a better way. And this requires a kind of different approach to thinking, how can we actually validate and verify a user's identity? So the concept that we looked at, can you go back please? Yeah, so the concept that we looked at was in terms of looking at it from an immediate family member. If one person is verified through the normal route, can that person verify an immediate family member? So the solution that we worked on, okay, very quickly, the blockchain that we're using is public Ethereum, because we believe that that is the only a very powerful blockchain in terms of its public benefits, in terms of its processing for smart contracts. The unique identity is mapped to an Ethereum account. Yeah, we'll go ahead. The user application, on the other hand, is in terms of a mobile smartphone, because that is the revolutionary device that will connect all spectrums. So there are three parts to the system. One is the user, the authorized institution, and the Ethereum mainnet. So let's walk through a first case. We'll go through a demo. So just to explain it, the first one. The first one is, okay, so we're having two individuals, Jack and Jill. Now, we're assuming that we can't abolish the KYC process altogether. That still needs to happen for one individual. So that's going to happen. The user is going to fill in their information with a mobile app with certain information supporting documents. That's going to be sent to an authorized institution. That whole KYP process is going to happen. The approval is going to take place. And sorry, just go back. All right, so what's going to happen is once the institution has done it and approves the identity, then we are actually, a smart contract will be executed at the Ethereum mainnet, which actually takes that person's ID. So let's just go to a demo, and we actually have this implemented. Okay, so I kind of rushed through that. What that means is for the first, what's really happening is the user will take the mobile application, fill in their details, submit that for approval at KYC. So let me take an example of Kathy here. So I'm going to enter Kathy's name. Okay, so I'm filling basically Kathy's details here. And just from a point of simplicity, they will have to enter some family information. But in this case, to make things simple, we're just entering their father's name and mother's name. So I'm going to put father's name as Chris, mother's name as John, and I'm just going to put a date of birth. Sorry about that, Kathy. Yeah. Well, that was a good guess then. Okay, so in this case, what I'm doing is I'm submitting that information, and I'm saying create an account. So what's going to happen is that creating an account is going to create an account in Ethereum for me at the mainnet. It will not be approved at that point, but because there is going to be a smart contract that runs in Ethereum that's going to check whether this can be approved by an immediate family member or not. In this case, it's not. So I think it's going to take time. Are we good? Okay, so we'll come back to that while that processing happens. Okay, so we'll switch back. Okay, so that's the first case. Now the second case that we're talking about is really kind of minimizing the KYC process. Is in this case, now assume there's Jill, who is Jack's sister, and she basically wants to do the same thing. So she is also going to access her app. She's going to create the same information. The account is created. It's going to execute a smart contract, the same one.
Now, in this case, there is going to be AI that runs in the Ethereum to actually validate that Jill is indeed Jack's brother, at least that's what she claims. And the push notification is going to go to Jack. Jack is going to approve the ID or not, right? They don't have that option. But in case he does approve, again, it's going to go to approval process in the Ethereum net, mainnet, and the QR code is active. So the QR code is really the ID that people are going to use. So let's go back to the system. So in this case, going back to Kathy, now that the transaction has happened, ID has been created. Has it been approved? Okay, so here is a pending account. So let's go ahead and approve it. This is actually, again, executing the contract in the, we're using a test net, of course. It's not the main net. We're advocating that it should. Okay, so now in this case, is she approved? Yeah. Okay, no problem. So what I'm going to do here is in this case, now assume that now I'm Kathy's brother, and I want to do the same thing. So I'm going to take my own photo, and I'm going to put in the same details as Chris and Rosa. Two, four, one, one. Okay, so I've created the account there. Now the same thing is going to happen. It's going to go up to the Ethereum net, execute the smart contract, discover that through that recognition, it's going to discover that Kathy is my sister, and she's going to get the request for approval rather than going to the institution. So while that's happening on the network, we'll get back to that. So just talking very briefly about the technologies that we use. So there's three components here. One is, of course, the Ethereum testnet. There's the mobile part, and we're using Android and W3J library. And on the website, we're using Node.js and a framework called Truffles, along with Web3 to connect to Ethereum. Yeah, these are the snapshots. Of course, they are very rudimentary. Now, this is the last thing that we want to access is about mobile mesh networking. Where does this come into the picture? Is if we're talking about the population that don't have identity, this is probably a system that could work. The requirement for all these cases is in terms of connectivities, in terms of networking. And so how do you solve that problem? Well, assume the same case in terms of Jack and Jill, and Jack has data connectivity, Jill doesn't. This whole same kind of process can happen if they're able to connect together. And so therefore, Jill can have instant approval through it by connecting to it. And so the networking platform is actually not just connecting two individuals, it can connect as a community. And that's actually the kind of thing that we're working. We've not implemented in the solution, but this is the key point that we want to drive, is that it's not really, when you think about the system, it's one thing about the blockchain and how that's going to reduce things for institutions from a KYC's perspective is very important, but you have to think about it end to end, including the user and the user benefit. So let's go back to the.
We'll take questions. Time's up.
Time's up?
Yeah.
Okay, we'll just finish it. So basically, what has happened is Kathy has got the approval request. So this is what Kathy's got. She's got an approval request from me. I will say approve. And then, the same thing will happen. What's going to happen is that it's going to move from the pending account into approved account. While we're answering questions, we'll see if that happens and comes into the picture. So I think we're done, right? Yeah?
Open for questions.
So that's basically the system. Of course, it's very simplified. There are a lot of things that we would want to do to make it into an MVP. For example, the kind of information that would be requested from a user, the use of AI at the system to do that kind of matching. The whole concept of having a family member to trust it, that could be probably brought down to different levels. So there's different things, but we wanted to bring that concept where you can reduce the inefficiencies of KYC at one side while providing a very easy and secure, easy user interface for the user.
Two questions. One, how do you think a bank can use this solution? And second, don't you think, in fact, this platform could be actually used by people with evil interest to form a group and probably certify each other.
I'm sorry, I didn't get the second part.
So probably this could be used for criminal activity. In fact, it could be a platform for a criminal network as well.
Yeah. Well, when we devised the system, we weren't really looking at it from a bank perspective. We were looking at it, we're trying to make it generic for a particular institution. It is, and so this requires thinking, it requires kind of forward thinking where the whole blockchain space is leading to. Rather than having centralized control of systems, it really needs to be broken down. And so probably it's not just one bank. The ideal situation is that multiple institutions would have to use this system together. Of course, that's going to take some time until we get there, but that's the kind of ideology we kept in mind when designing the system.
So this comes across as a generic identity management kind of solution, right? So what
global unique identity, you can think of it something very similar to Aadhaar. I think Aadhaar is a great system to manage identity, they're tracking it, talking it from the roots. Of course, there are the issues in terms of its centralization and that part of, again, having it within a certain rigid framework, let's say, put it that way.
So when we read the problem statement, it was an existing problem of KYC, which we wanted to solve using the blockchain. So now you come up with the solution, but I don't understand what kind of problem you're trying to solve. This seems like a value addition, but what kind of motivation do I have to be on board with this?
Motivation for the bank specifically is in terms of the inefficiencies that you have. So just in terms of time and cost.
Stop you right there. This is not just from a bank perspective. In general, why would I want to be a part of this?
And you are an institution or a user?
Individual, anything. I'm an individual.
You're an individual. Well, you needed identity. So this is what we focused on is really the whole creation concept of it. But the ID is important. So now whether that is an ID, what we're extending is why we're using Ethereum as a global blockchain is that the execution to have it flexible, having smart contracts, considering giving the example that all other systems would be able to use it as an identity system. So whether you need to go to a government office, whether you need to have go to university to publish your records, to obtain your records, whether you need to use it for healthcare kind of records, this should be that one ID. So it's basically the use of the ID is not what we got into too much detail on. We were focusing, zeroing on the problem of creation of the ID. But then once you have that, this should be basically your one unique identity that you could use for all services.
So how would an enterprise create an ID on the system? And B, what happens on fringe cases where no one has a family member that they could actually verify using?
So again, the system has been kind of thought of from a consumer standpoint. It could be evolved from a corporate standpoint as well. The information that would have to be entered would be slightly different. It may not be immediate family member. The underlying concept is that someone who can actually vouch for you, someone who can actually vouch for your identity, which will reduce that particular time. So there are different ways probably to customize it more towards an enterprise environment. The second question? Yeah.
So if anybody can vouch for me who's not my immediate family member, what prevents me from creating multiple IDs to just verify myself?
No. So going back to that second question in terms of what happens if you don't vouch, well, the KYC, the existing KYC process is still what is going to happen by default if the person, like for example, a family member chooses not to vouch for you. So it's still going to go through that existing process as it is today. We are just looking at a way of kind of minimizing the process or minimizing the time as you can. So you can't abolish the KYC process. That's still going to happen. This is just kind of adding on to that.
Sure. Thank you, Tech Research.
Thank you.
Okay, guys, finally we have last two teams remaining. One is Unique, and next up is Clay Bars. Hello.
Hi guys, so we are Team Unit. Yeah, sure. So hello everyone, we are Team Unit. So basically what we have done for this hackathon is we have thought about the concept of a digital identity, like what a digital identity will look like on a blockchain, and we have tried to make an architecture around that, and we have a small proof of concept, minimalistic proof of concept. So the pain points around KYC nowadays are like KYC is supposed to be know your customer, but it sounds more like it's killing the customer right now. So right now the KYC process is something like if I am an individual, I go to some, if I want to avail some service, I go to a say bank or government, whatever. So they will basically require my proof of identity and something like that. So they will offload that all those verification details to some other third party. That third party will basically validate me by their own ways maybe, and then they will store all that data in a private repository anywhere, right? So, and as you can see, this is siloed kind of. So that database belongs only to that particular entity, right? So, and this, if I want to avail service from some other entity, say some other bank or some any other entity, then you have to again go through the entire same painful process again. So the current process is very costly because you have to because every time you need to keep doing the same thing again and again, and also it is uncoordinated. So the different entities, they might be getting more value if they coordinate like the data validation procedure amongst themselves, and it is repetitive, since it's repetitive from the user side because he has to keep doing this again and again in a way, right? So this is our architecture. So basically what we are thinking, so this is what we call this is what we call a physical real world identity, that guy. So that guy can also, right now we are showing it as an individual, but it can also be something like an organization of any sorts, right? So right now if the user in our system, if the user wants the first time that the user wants to get in the digital world, he first time the onboarding process will go something like this. He will go to some institution. So right now we are assuming that it's the government. So he goes to the government, and the government asks for his details, and he verifies all those details in a way. And after that, basically this all after verification has been completed, so the government will attest to whatever attributes of that particular person or organization that he has already done, and he will create a digital identity which is basically what we are assuming it to be is an Ethereum address on the public blockchain, right? So, and after doing this, basically, so this digital identity is the thing which maps that person into the digital world, right? And now what we want to do is that we want to take this particular digital identity, and right now, since the first, suppose the government has verified this particular person, right? So what we want to do is that take this digital identity and map it to what we call a virtual identity, which will stay on the blockchain. This is what we are putting on the blockchain, right? So so right now the process will go on something like this. So basically the user will, suppose the user comes into the system, there are many different kinds of entities, and we are assuming that all these entities will work together in coalition in some way, because if like suppose the government gives an Aadhaar card and the bank requires an Aadhaar card, right? So we require all these different related entities to be in the same domain, in a sense, right? So now, once this guy gets all his verification done, as we showed in the previous slide, it's his virtual identity is put up on the blockchain, right? And right. So now if if any other entity, say another, after doing this, he goes to another bank, and that another bank wants to verify his details, right? And that another bank, we are assuming that that bank is going to trust the entity who signed off his previous virtual identity, right? So in that case, he will the other institution, whatever he was, he will give whatever service he was supposed to provide him in the first place. So now there is another problem. Like suppose that that guy, he committed some crime or something because of which his Aadhaar was invalidated by the government, right? But we don't want that guy to go off to a bank and show that, see, I have that virtual identity which was signed earlier by the bank. We want to have some sort of linkage between what lies on the virtual identity and basically we don't want the actor to misbehave in any way. So what we will do is, as soon as the government invalidates his Aadhaar card, a record for that is also put up on the blockchain, right? And because of that, he cannot, if he wants to show a bank that particular identity, he cannot do that because the record shows that it has been invalidated. So it will be an extra update of that particular virtual identity. So this is cost effective because the onboarding process is just a single time. And this is coordinated because each of these entities right now, they are coordinating amongst themselves, and you don't have to do it again and again. And as we said, it is a non-repetitive process. So now we'll show you a simple, like very minimalistic demo of what we have done. So it's extremely simple thing right now. So what we have done is we are creating a contract, right? So the contract basically has certain functions, as you can see here, which is we have a function called add identity, right? So adding the identity is as simple as so it is basically an Ethereum address followed by some unique ID and the age of the person. So we are just taking it as hard-coded elements right now, and we add that particular identity. And now if we want to check that particular thing, we can see that all those things are updated on the blockchain in a way. And now suppose the thing that we talked about, if the guy misbehaves in some way and the government wants to invalidate his records, so what the government can do is basically enter his details and use the make invalid function. And then as you can see that earlier the is valid function here is true, but now after doing this and again checking the same thing, the is valid function becomes false in a way. So if anybody wants to use that particular information, he won't be able to use it again. So this is pretty much what.
So what happens if the government wants to update or anybody wants to update?
If the government wants to update it, basically they will have what we talked about as a virtual identity is basically a smart contract on the blockchain, and that contract will be owned by the user owned by the digital identity, and there will be a certain number of functions which will be which the government can access within the smart contract. So basically there will be a function through which the government can change those particular attributes and it will get reflected onto the blockchain in a way.
And can anybody who has access to your hash ID, public hash ID, access all the details of your?
No, like right now we have just shown it like for simplicity's sake, but the data we won't be storing it on the blockchain.
Where would the data be stored then?
Data will be stored there will be hashes to the user's data on the user's phone, which will be stored in some offshore database, like it can be IPFS, or it can also be any other centralized database that the user trusts, that the user can trust to safeguard his information in a way.
So what I see here is in the contract, you've already stored some kind of information in the blockchain. So you're talking about media files which you want to store in different file systems?
This won't be stored on the blockchain. This is just for the proof of concept, basically.
Okay. And so you basically covered all the functions that the problem statement described. But what would how would you differentiate yourself to the other teams?
So like how we differentiate is that we partition the concept of identity into multiple things, right? Like how there's a concept of a user in the physical world, and that concept of the user in the physical world cannot be directly that particular user's identity, you can't directly put it on the blockchain. So we put in a level of indirection, which is the digital identity. And through the digital identity, you can have multiple virtual identities, which the user can use. Like suppose the user wants to go to a bar or something, and the bar owner needs to know that that guy is above 18, right? So in that case, this identity can also be used in a way to the user can just point to the public blockchain, say that this particular government organization has signed off saying that I am above 18 indeed. So and if that bar owner basically, if he trusts the government, then he can use that particular information in order to like let the guy in or something like that.
So that's one good thing I liked about your solution, that you have introduced a level of authentication by which you are mapping the physical identity to the digital identity. So that way you know that this particular digital identity or address belongs to that person. Otherwise, there's no way a person could create multiple addresses. So I think that's a really good aspect that you've included. The second thing I wanted to ask about, if you could go back to that slide, so that make invalid function, can that be misused? How could you restrict the use of?
So basically, if I'll go back. So if you see in an Ethereum contract, you can have like specific permissions for particular things, like something like a modifier which says only issuer, and you can put, since it's a smart contract and it's a Turing complete language, so basically you can build in those rules that if you want only the address which belongs to the government, in order to make those modifications, you can include those in the logic of the smart contract itself.
Thank you so much.
Next up is the last team, clay bars.
So hello everybody, my name is Michaela and I'm now the first time here in India, and I arrived 3 days ago, and I registered for a SIM card and I still don't have any access to it.
Hi everyone, I'm Stefano. I'm Italian and I work here in India. It took me 3 weeks to open a salary account.
Hi everyone, my name is Smriti. I'm a risk and financial advisory professional. Born and brought up in India, I have all valid IDs, and every time I change a city, it's still a difficult process for me to get my bank account transferred to the nearest bank.
So maybe first some expectation managed beforehand. We want to concentrate on the business logic and not on the nuances of the application. So why are we talking again about all of this? So very clearly, this topic is one of the most cost-saving potentials for all banks right now. And this is at the same time creating the most competitive pressure. So if one bank goes ahead, the others will really fall out of it. So when you think about just AML, there it's $10 billion per year, which is spent of all large corporations. And 30% of the budgets for all large corporations are actually on this topic. So, and right now we don't really have focus on what clients actually expect from the banks. So what we just were already talking about, everything is very slow, and we don't really know our clients, or financial services don't really know our clients. So also then for clients, the same thing, and for also like legal bodies, they have to invest a lot of money in auditing. They don't really have transparency right now. So what we really want is like the client should be in the center of everything, and especially for this topic. And so everything what's digital, we really have privacy concerns. And especially if we are thinking about a larger model, which is a global model. So we have different legislations, and we think about that we should stick to the most conservative legislation. For example, data privacy in Europe is right now the most conservative one. Then we also want to have a system which is sustainable. We don't want to change if we implement it again. We want to be able to have a dynamic and openness. We want to be able to extend it and also take on more stakeholders on it. So at the end, what we want is a shared service center for a banking consortium. So we were thinking about different options, how we could create this. So a repository, for example, of a legal body seems like the most obvious. But now when we think about checking the boxes for our guidelines that we just were presenting, those are not yet fulfilled. And also it's not central, and we don't have the information that we really need as a bank. So we would need to wait like years until we would get it. Doesn't work. So when we think about all banks in the world or several banks, and we exchange KYC, we have the legal issue, we don't get around it. And it's complicated, it's intransparent, and there's also competitiveness. So the third option is the client wants to have a service from a bank, and he's giving the information on a permissioned blockchain. This is then validated by regulators, so they are at the same time than the body who has actually the accountability. So it's not actually held by the banks anymore, it's with the regulatory bodies. So when the client wants to open, for example, in a bank account, he can say, I want to give certain information to the bank, and the bank can access it. So he is under control of it. So we can check actually all the boxes. Plus, we also are very, it's very simple, it's customizable, and we can really reduce our overhead and then over the whole system. So the competitive pressure is going.
So let's talk about information. KYC today already collect information from the user and from third party. However, with our solution, we will add more third-party sources in a dynamic way, and these sources are trust. This will bring lots of benefit. Let's take these three uses case. For an individual, for example, as I mentioned before, I'm foreign, I'm not Indian. I can use my foreign bank history to open my bank account. It will be quick and fast. If I'm part of the billion of people who are outside the banking industry, outside of they don't have any financial service for them. They can use their ownership right to access to any banking products, or the utility bills repayment, a track history of their repayment. Or if I'm a business, I can use my credit score, I can use my bank history. With a futuristic approach, I can use my IoT business data that can be put in the blockchain to verify my KYC. So this will bring enormous benefit to the banking sector as a whole.
So coming to how our solution actually works, one entity is the user, which might be an individual or a business. The other entity are the banks. Now, coming to the actual identity repository, we have some public information and we have a permission blockchain. This permission blockchain has all the regulators as nodes. How it works is the client, the customer wants to have wants to get a digital identity. It creates a transaction. It is received based on you depend on multiple signatures to get it validated by the different nodes, and you send back a identity number back to the customer. You also, when adding the transaction to the block, you put a hash on the public information. Now, when the user wants to share that information, all it has to do is it has to generate an OTP, use that to transact with the with the bank, and The bank can then first go to the publicly available information, get the hash pointer back, then refer to the identity repository. If the OTP and the ID matches, then the information is shared with the bank. Another benefit here would be that, because we also have other third parties, like let's say a passport office is a node. When my passport expires, they can automatically invalidate that, this passport number is not no longer valid. So it's dynamic in that way. You don't need to do like a constant KYC again and again. Uh, yeah, so basically this is what I was talking about in the validation. Wait, so who gets to create the identity here? The user. How we do it is, so we've just put some wireframes. You fill in the information, you submit, goes to the identity repository, it gives you back the identity number and the status. Who gets the control to share it? Again, the user. Here, as you can see, if I go to, let's say, a bank and I want to buy their product, what I'll do is I'll go to, it asks for this OTP thing. I go to the other interface where I can select what all information I want to share them with, generate an OTP, and use that OTP here with the bank. So this is just an illustrative stack for our solution where we thought of listing down all the components that go into building the solution. Now, why use blockchain? This has to be a shared ledger. We are actually leveraging the shared ledger aspect of it than the other features of blockchain. Obviously, we want multiple writers because we want the control of identity creation to rest with the user, to have that authority. And absence of trust, we obviously don't want fraud. So when we have different regulators and different civic bodies on the permission blockchain, they can keep validating and verifying that information. Also, a lot of teams talked about scanning paper documents. I would like to point out here that our solution is not at all dependent on that. Because here what you have is, I don't need to scan my passport at all. I don't need to save a scanned copy at all, because my passport number is getting validated by the passport office itself. KYC and beyond. Obviously, cost optimization, reduced customer onboarding time, and better customer experience. All these things are what is obvious from our solution. Now, if you want to take it one step further, you can use it for AML, trade finance, a lot of services that are listed. And if we try to be a little more futuristic, once you have all of this data, what you can actually do, and this is just one of the possible use cases, is what if I can, based on the customer information that I have, generate specialized interest rates or customized products for that particular person. We already have algorithms trying to do, trying to detect who is going to default. If we think along those lines, maybe if you see a pattern that this person is going to default, rather than waiting for him to default and then doing asset restructuring or whatever, you can take preventive steps for that. So that is where that's slightly futuristic. Also, identifying ultimate beneficial owners, but these are all like slightly more complex algorithms, and we are over time. So I would like to close. We would just like to end by saying that the problem at the beginning that we started with was that banks don't really know the customer. And what we are ending it at is that banks knowing the customers better than we know ourselves. Like here, we want to leave you with the thought that you can give me rates and products specially customized to me for my needs. So yeah, thank you.
Have you guys actually built anything so far? It's conceptual. All right, no worries. One advice, if you do decide to build it out, don't use OTP, because that will be the weakest link in your transaction chain. All right.
So when you started your presentation, you talked about all the different problems you have when you want to move to a different city and other things that you mentioned. So every time you create an identity, it's been verified by everyone. But a common problem, and myself included here, is that all my identities don't match. My name doesn't match, and other information doesn't match. So every time I try to create the entity, my identity, it might fail somewhere, which kind of defeats the purpose because as an institution, say the passport office is doing its job, the Aadhaar is doing its job, but it's not matched. So I'll have to personally try to normalize all my information everywhere, and only then can I set this up. Do you have any thoughts on that?
So first of all, that is a problem, and that's a problem with the blockchain in general. That blockchain inherently does not authenticate, cannot authenticate data. So any system is as good as the information it is consuming from, consuming any source that it is consuming data from. Now, to answer your question, A, if I know that I have a discrepancy between my PAN number and a passport, let's say, when I'm trying to share the data, right? In all likelihood, I don't need to share all that information. Probably I'll just share the information that has consistency. If it so happens that all your IDs have completely different names that don't match, then I agree, like, then it's no longer a problem of this solution, like this system, but a problem of the digitization efforts that have been taken by the authorities. So yeah, it is a vulnerability, it is a risk. The way you can like minimize it, I would say, is by having cross checking it with different parties. Like, so what I'm trying to say is, once you use the blockchain identity ID that we're talking about, if I can link that, so I won't check your name with the PAN office. I will only check your PAN number. Okay, so whether your name matches or does not match, or your address matches or does not match, I'm not dependent on that. So it is also a question of what authority I'm using for for which information field, I would say.
So if you could go back to that slide where you have shown a public public blockchain, and then there's this other private one where you have signatories. Yeah. So my question is, why do you need that public information and that hash over there? So the whole concept of blockchain is about untrusted parties, collaborating together over blockchain. So why can't a single blockchain where you have all these multiple signatories, why can't that itself be available? Because you can still encrypt the information that is available. So it's not really exposing the data to the entire public.
So encryption services are not just for blockchain, they can be applied to any traditional infrastructure as well. What the reason why we have two blockchains is whatever is publicly available information, maybe we want to keep here so that this does not need that many referencing. And also we have hash pointers, so we don't want the banks to be nodes on this blockchain. We want to have like a two-step referencing, so that like how do I put it? Like, it's basically like, you're trying to minimize the risk of somebody unauthorized accessing that information. I hope that's answered. Thank you.
All right, that was the last team. We'll just have a quick 10-minute break. There's wine and some snacks over there. You guys can go and have it, but we'll ask you to come back while we calculate all the scores and announce the winners. I'd also like to ask the judges for just a couple of more minutes and join me in another discussion. Thanks.